Dear students, welcome you all to this first class of compiler construction. Let's start from introduction of this course. The main objectives of this course are we will try to learn the basic techniques of compilation theory, and after learning those techniques, you will be enabled to write more efficient programs. It's also the objective of this course that you become enabled to design your own mini language, as well as for your own mini language, you can practically implement compiler's front end. There are few subjects that we are assuming that you must already have the knowledge of these subjects. First of all, you should know the main two programming approaches, functional as well as object-oriented programming. Also, you must have the basic knowledge of data structures and algorithms, theory of automata, and assembly language. This is the textbook we will follow. Compilers, principles, techniques, and tools. And its 3 editions are available in market, but the second edition of this book is available online. And I have given the link from where I have given the link in comment section from where you can download this book in PDF form. I'm your course instructor. My name is Nauman Kadir, and you can contact me throughout this course with the help of this email address, nauman.kadir@fuuast.edu.pk. Okay, let's move to the structure of today's lecture. Today, first of all, we will see that why we use language translators. Then we will see that what are the main types of language translators, and after that moving towards high level languages, because there are two types of translators, compilers and interpreter. We will see that what's the difference between compiler and interpreter, and also we will see some languages which use compiler as well as some languages which use interpreter, and as a special case there are few languages that use both compiler and interpreter. So we will see what are those languages. Next, we will move to the main objective of this course, means the compilation theory, and we will start from definition of compiler. And after that, we will see what are the main types of compilers, and then we will see the compilation with some detail, and we will see that there are 6 phases of compilation, and sometimes these phases are categorized as analysis, synthesis model. So we will see that what that model is. Okay. So why we use language translators? The answer is very simple, and I think you must know it, already know it. As you know that computer is an electronic device which can understand only 2 states of electricity, on or off, which can be represented by 1 or 0 respectively. And that's why computer can understand only the code written in machine language. That's the language of zeros and ones. And all other languages use English-like words and sentences, so they are not understandable by computer, and that's why computers use language translators for those languages. What are the types of language translators? For seeing the types of language translators, first of all, we will see that there are two main categories of uh, computer languages: low-level languages and high-level languages. And within low-level languages, there are two languages: machine language and assembly language. Machine language is the language of zeros and ones that is directly understandable by computer, or you can say the hardware. And assembly language is in fact the mnemonic version of machine language. You can say mnemonic or symbolic version of machine language. So these two languages are low-level languages, and assembly language, because it is written in English-like sentences. So assembly language needs a translator. Its translator is called assembler. So rest all languages are high-level languages. And for high-level languages, we use two types of translators: compilers and interpreters. So we can say that there are three types of translators: language translators, assemblers, compilers, and interpreters. First, talk about assemblers. Assembler is only used for an assembly language, which I already told you that that is the symbolic version of machine language. So one assembly language instruction is converted into exactly one machine language instruction. That's the way assembler do its work. However, this work consists of two passes, and what are those two passes and what's the two-pass assembly process, we will learn it in next lecture. Next, there are other two language translators: compilers and interpreters. Some languages like C, C++, Pascal, COBOL, Fortran, etc. use compilers. One thing is common within these languages, and that is all these languages are non-scripting languages. Whereas whenever the language is scripting language, like JavaScript, like Python, like MATLAB, BASIC, Perl, Smalltalk, these languages programs are interpreted, not compiled. So you have seen some languages which use compiler, and also seen some languages which use interpreter. But there is a special case for few other languages like Java. Java program first compiled into bytecode, and then that bytecode is interpreted through a special software called Java Virtual Machine. And this JVM understands its corresponding operating system, whether that operating system is from a Macintosh family or Windows or Unix or Linux. So that's the way we say that Java is platform independent language. In fact, its program is processed through two stages. First, it is compiled into bytecode, then it is interpreted through JVM. Similarly, C# or VBNet, their programs can be executable on any Windows platform, but their programs first compiled into MSIL, which is known as Microsoft Intermediate Language, or also known as Common Intermediate Language. And after that, these format MSIL, or you can say CIL, is these format programs are interpreted through CLR, which is known as Common Language Runtime. It's an interpreter. Okay. Now come to the difference between compiler and interpreter. Compiler translates and executes whole program, whereas interpreters translates and execute the program line by line. Because of this uh, nature of compilers, we can say that compilers are more efficient or fast, whereas in comparison to compilers, interpreters are slow. As I have already told you that compilers are used for non-scripting languages, whereas interpreters are used for scripting languages. There is another difference that compiler reports all errors in the program, whereas interpreter cannot report all errors because it stops at the first error of program. But interpreter has some advantage of it that your program executes until an error is occurred. It means it is possible in case of interpreters that a program can partially execute because the execution is line by line. Whereas in case of compilers, there is not possible that program will execute if any error is occurred in the program. Okay. Now move to definition of compiler. Compiler is a software which translates a high-level language program called as source program into a target program, which is usually a low-level language program. And during this translation process, it also reports the presence of errors in the source program. Okay. As I already told you, that target program is usually low-level language program because the compiler's purpose is to translate and execute a program. So that's why the target program is low-level language program. But sometimes compiler techniques are used to translate a high-level language into another high-level language. And in that particular case, the target program can be high-level language program. There are few types of compilers like single pass compilers, multi-pass compilers, load and go, debugging, optimizing, and many more. These are the types depending upon the functions which we are supposed to perform by these compilers. But despite this apparent complexity, the basic tasks that any compiler must perform or the basic theory behind these all types of compilers is same. And that's the main purpose to read this subject, to learn this subject, that we want to get an in-depth knowledge of that basic theory of every type of compiler. So let's see the inside picture of compilation. We can say that the compilation process depends upon 6 phases. First of all, your source program is lexically analyzed. By lexically analyzing means your program is scanned character by character and from the first line of instruction. What lexical analyzer do is it sees the stream of tokens and identify tokens. So uh, what is the meaning of tokens and other details behind lexical analysis? We will see it in detail in next lecture. So after lexical analysis, your program is hierarchically analyzed. By hierarchically analyzing means your compiler sees that whether your programming instructions are according to the grammar of language or not. So we will see this phase of syntax analysis in detail in next lecture. And after the successfully analyzing syntax analysis, the third phase is semantic analysis, which means the meaning-wise analysis of your program. So first of all, your program, the main tokens or main, you can say the elements of your program are identified in lexical analysis. Then after that, those elements are hierarchically checked by the grammar of your language. So that is through syntax analysis. Syntax analysis is also called hierarchical analysis or parsing. And after parsing, your program is checked meaning-wise. Or you can say, for example, if the identifiers or variables are involved, then what is the types of variables are compatible or not. Like these kind of issues are uh, identified or checked within semantic analysis. So after successfully lexically analyzed, syntax analyzed, and syntactically analyzed, your high-level language code is converted into an intermediate code. So what is an intermediate code is? Intermediate code is a code written in a high-level language, but it follows the properties of low-level language. So what's the property of low-level languages? For example, we have seen some instructions of this assembly language. You can see here, within one instruction of assembly language, it is instructing to do a single task of, for example, here, subtraction of something, for example, here, moving of something, like this. So in high-level language instructions, it is not necessary that within one instruction, there is only one operation. But in low-level language instructions, it is necessary that there is only one operation in addition to the assignment operation. For example, sub AX comma BX. Here AX and BX are registers. It means the contents of AX are contents of BX are subtracted from contents of AX, and the result is stored in AX register. So it means there are two operations are going on here. First one is subtraction, and the second one is assigning that the subtracted result in somewhere. So the quality of low-level languages that there is only one instruction, maximum one instruction, in addition to assignment operation. Okay. So intermediate code follows this property of low-level languages. So in next lecture, we will see these 6 phases through some practical example. Then you will get more know-how about what is an intermediate code is. Okay. So I repeat, the high-level language source program is first lexically analyzed, then syntactically analyzed, then semantically analyzed, and after that, it is converted into an intermediate code. And after that, this intermediate code is optimized. By optimization means trying to make a code better, which means, for example, if some code is written in 7 instructions, or let's say 6 instructions, if it can be converted into 5 or 4 instructions, then it means your code is optimized. How we'll do this? We will see its demonstration through a practical example in next lecture. So after this fifth phase of code optimization, the last phase is target code generation. As I told you, In case of execution of a program, the target code is a low-level language. So after code optimization of an intermediate code, this intermediate code is converted through this phase into low-level language code. So if this target code is assembly code, then it means it further needs an assembler to convert it into machine code. But if it's target code, it means you have designed this phase as the target program is directly the machine language program, then it doesn't need any translator further. Okay, so I repeat, what are the 6 phases of compiler? Your source program is first analyzed in 3 ways. First one is lexical analysis, then syntax analysis, then semantic analysis, and after that it is converted into intermediate code, and then this intermediate code is optimized and converted into a low-level language through the last phase of compilation. So these are the 6 phases of compilation. And here is another picture of these 6 phases. And this picture is a more broader view of this compilation process. In fact, from source program to target program, we can see 6 phases here, but we can see the additional information here that these 6 phases are related to 2 other routines. First one is error handling, and the next one is symbol table management. So what is symbol table of compiler and how it is going to manage through these phases? Similarly, how the errors are reported within the source program through error handling routines. These are the topics of our next lecture. Okay? But the purpose of showing this picture is you must know that these 6 phases of compilation have correspondence with 2 other functions, the symbol table management and error handling routine. The last topic of this lecture is sometimes the compilation process is called analysis synthesis model. Why? Because if you see the first 4 phases, then your source program is converted into intermediate code after 3 kinds of analysis. So conversion of source program into intermediate code means through these 4 phases can be grouped as a analysis task. The next 2 phases can be grouped as a synthesis task. So in this way, we can say the whole compilation process is analysis, synthesis, model. Okay. So let's meet in next lecture with a practical example of demonstration of these 6 phases. Thank you.